Okay, so how are we going to do this intelligently so that I'm not just essentially repeating the exact same work again? All right, we will do one from each. Three take 20 is minus 17 minus 32, so minus 49. Then the next one, 0 would just be 0. Next one, okay. Whatever that happens to be as a decimal. Check. Correct. Check. Correct. Check. Correct. Check. Correct. Next one. The difference quotient of a function f of x is defined to be this. F of x plus h minus f of x all over h. Okay. Compute the difference quotient of the given function. All right, so to be smart about it, we're going to do what the easiest one and the hardest one of the bunch. So this one. That minus all of that over h. This should result in 4, as the objective is to sort of find the gradient function of the base function, if you like. So it'd be 4x minus 4x. Good. And now for the 9th one. And all of that divided by h. Okay. And all that has to be divided by h. All right, so some very messy looking function here. And then all of that is divided by h, so a factor of h would be there as well. And now to actually carry out the multiplication, like that. All right, okay, so, and then all of that is multiplied by h. And what somehow this is going to simplify, I think not. But anyway, we're going to now get the numerator. Okay, so that'll be 6t plus 6h to take 2t squared, take 2th minus 6t plus 2t squared plus 2th. And what cancels? That one, and 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 that one. So 6h on the top, so 6 on the top. And on the bottom, 9 take 6t plus 9 take 6t plus t squared. Take 3h plus th. Like that. Now, I don't know if that's right. Top one looks fine. Okay, they just don't want to expand it out on the bottom. That's fine. Determine all the roots of the given function. Okay, so that one will just, that one we know that's fine. All right, we I don't know how to get the 17th one just yet, and I don't know how to get the 15th one just yet. So that's the one that I'll actually do, the one that I don't know how to do, or that doesn't come to mind immediately. That's smarter studying. Okay, so what I'm going to do is I'll just let let w equal t to the 1/3. So it becomes w to the 5 take 7 w to the 4 take 8 w cubed. Now factor, and again, and w would be 0 or 8 or 1, and if t to the 3rd is 0 or 8 or 1, then t would be 0, 512, or 1. So I believe. The other one I don't know how to do right now is 17. There. B squared minus 4ac. 81 plus 48 then. Be 129, so you can't factor that one. So 1 plus. So that one you can factor that one. Oh, what am I talking about? Of course you can factor. Of course you can factor the denominator because it's a product of those two. I mean, I don't know why I did that. But as for the numerator, did I multiply that out right? 4w squared take 6w. That's what that should be. 4w squared. That's better. And so now that will become 5w. Yeah, 4w squared takes 6w. And then w squared take 3w take 4. And that has to be added on. So that's all good. All right, redo delta b squared minus 4ac, so 81 minus 4 times. No, still not factorable. B squared minus 4 times 5 times minus 4, so b squared plus, so 81 plus 80, so 161. So yes, you really can't do it. And so the zeros on this will be the ones that look kind of complicated, right? Oh, that should have been a minus. Okay. Yeah, so just QF. Next. All right, all of this is fine. Know how to do that. Inverting functions. All right, now the really important one. Yeah, so the inverse of that is will think this first multiplies a variable by 6 and then adds 15. So the inverse of that is first taking 15 and then dividing by 6. So generalize. Like that. The next important one to generalize is this down here, 7 and 8. So first I'll try and just do 8. Six takes 7x over 8x plus 10, like that. Now generalize. Okay, that's fine. Ax plus b over cx plus d. So we say y is equal to ax plus b over cx plus d. We bring that up. Expand. Bring the x terms together. Cxy, take ax, and that on the other side. Factor out x. And so the inverse becomes b take dy. Whoops, swap out for x. B take dx over cx take a. Like that. That's good enough for that set there. Try the next one. Trig functions. Okay. All right, so we'll do all these and then finish up. Yeah. All right, cosine of 5 pi over 6. Okay. Root 3 over 2. We'll do 3 at a time and then check them. Sine of negative 4/3 of pi. Okay. What's a third of pi? Come on. 60. Right, okay. So root 3 over 2 as well. And try this one. sine of 7 pi over 4. So that's 1 and 3/4 of pi. Half a pi. Minus root 2 over 2. Check, check, check. Oh, what? Oh my gosh. Okay. Pi at the bottom. Okay, okay. Let's check here. I'm pretty sure about that one. Yeah. This one. Yeah. Okay, next. Tan of 3/4 of pi. Okay. Minus 1. Secant of negative 11 pi over 6. So straight away, I go to cosine in my mind. Okay. Go to cosine. $30 before the end. Okay, so root 3 over 2. Inverse 2 over root 3. Oh no, wait. Oops. Uh-oh. I missed that out. Just move everything down. Cosine of negative. Oh no. I don't know, my laptop wasn't plugged in. Okay. Minus half. I think. Check, check, check. Good. 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 Just a few more. Just a few more. Cosine of 8 pi over 3. Two-thirds more. Minus half. That's 3 1/4 pi. Yeah. No. Yes. No. No. Yes. No. Yes. What is it? 15 pi over 4. That's 3 3/4 of pi. Okay. So. Okay, and then -1, I think. Check. -1/2. -√3. -1. Last two. Sine of -11 thirds of pi. -3 2/3 pi, then yes. It's 2 pi. -3. -3.5. -3 2/3. √3/2. Secant of 29 pi over 4. Okay, that's cosine. Cosine has a period of 2 pi. 29 pi over 4, that's 7 1/4 pi. Reduce that, 1 1/4 pi. Then a quarter. -2 over √2, I think. Check. Good. Oh, wait. Oh no, that's actually fine. Oops. Yeah, because they're equivalent. I should have reduced it. All right, fine. Okay, I did what I intended to do. Excellent.